Question 26. Copper 2 oxide is reduced to copper as shown. The burner is then turned off, but the hydrogen is kept flowing until the tube is cold. So in this setup, hydrogen is being used to reduce copper 2 oxide. We know that in the reactivity series, all the metals, including iron and below, can be reduced by hydrogen, while zinc and all the metals below zinc can be reduced by carbon. The more reactive metals above zinc has to be reduced from the oxide by electrolysis. This reaction of reducing copper 2 oxide to copper only occurs when there is heat. Therefore, the burner is used in this case to provide the heat for the reaction. Let's write down the chemical equation for this question. The reagents will be hydrogen and copper 2 oxide, and copper 2 oxide is reduced to copper, and water is the byproduct form. So to answer the question, what is the main reason why hydrogen is kept flowing? In fact, flowing until the tube is cold. Statement A states it is to lessen the risk of explosion in the hot tube. We can see that in this reaction, there is in fact no explosive metal being formed. Copper is a very unreactive metal, and with only water as a byproduct, there will be no risk of explosion in this hot tube. So statement A can be eliminated. Statement B states to make certain that the reaction is complete. This may sound true at first glance because yes, we need to keep providing or supplying the hydrogen so that all of the copper 2 oxide can be reduced to give all of the copper metal. However, this is not the reason why hydrogen has to be kept flowing until the tube is cold. Because essentially when the tube is cold, this reaction cannot occur anymore. So there is no reason to continue supplying the hydrogen when there is no more heat. So this statement doesn't completely justify why hydrogen has to be supplied all the way until the tube is cold. For the reaction to be complete, hydrogen must be supplied all the way when the tube is hot. And it doesn't matter anymore if hydrogen is continued to be supplied when the tube is cooling down, because heat is needed for this reaction to occur. Therefore, B can be eliminated. C states to prevent the copper from reacting with the air. This is true. Although copper is an unreactive metal, in the presence of heat, copper can react with oxygen in the air to give you copper 2 oxide again. And this reaction serves to reduce copper 2 oxide, but if the reverse occurs, this reaction will be incomplete. And this oxidation reaction will occur as long as there is a source of heat. Therefore, we need to continue supplying hydrogen gas into the tube so that no oxygen gas can enter to react with the copper in the presence of heat. Only until the entire tube is cool, then oxygen can start to enter, because without heat, then copper will not react with oxygen. Therefore, statement C is correct. Statement D states to remove any traces of water left in the tube. Water is the byproduct that is formed from this reaction, and continuing to supply dry hydrogen actually does not remove water. This is not a dehydration method. Therefore, option D is wrong, leaving C as the correct answer.